Good morning, everyone. Dr. Nat here. So I am recording from my iPad. So this is the question that I am answering first. Question number 10 for your assignment, chapter 7. So a DMA module is transferring characters to memory using cycle stealing. Now in our class, we only covered cycle stealing and not burst. So just focus on cycle stealing from a device transmitting at 8600 bits per second. So here I wrote it here over here. And then the processor is fetching instructions at a rate of 1 million instructions per second, or this abbreviation is given 1 MIPS. By how much will the processor be slowed down due to DMA activity? So DMA is not exactly slow, but it slows down the processor because the processor has to pause whenever the DMA is transferring data from the DMA module to the memory. Remember, we had cycles: 1 cycle time, 2 cycle time, 3 cycle time, and the DMA will come in between this cycle and make the processor pause, if you still remember. Okay, so now let's move on to the how to answer this. So we have, I wrote down here 8600 bits per second. This is the rate the device is transmitting. And then we have 1 MIPS, which is the rate that the processor is fetching. Now, the processor is fetching 1 million instructions per second. I need to know how much time is needed to fetch one instruction. So what I do is I would divide 1 second by 1000 instruction to get the time for one instruction. So this is what I got. So the answer is 1 microsecond per instruction. Now this will be our cycle time. Because why? Because each cycle time is used to execute or to fetch and execute one instruction. Okay, one instruction. Okay, so this is our cycle time. So therefore, the processor will access the memory every 1 microsecond. So now we have 8600 bits per second. And it tells us that we are transferring characters. Here, we are transferring characters. So one character is actually 8 bits or 1 byte, which is also the same size as word. Sometimes words can be larger, but for our class syllabus, we always assume it to be 8 bits or 1 byte. Okay, so now we know that this guy is 8600 bits per second, and we know that 1 byte is equal to 1 character. So 1 byte is equivalent to 8 bits. So I'm dividing 8600 bits per second by the bits. So this will cancel out. Oops, sorry, not that one. 8 bits. So the B and the B will cancel out, and I am left with the capital B. So 8600 divided by 8. So I would get 1075, and I am left with bits over second because this is per second. Okay. Now moving on, what does this value tell us? This, oops. I need to undo this. So what does this tell us? It tells us that we are transferring 1075 bytes per second or 1075 characters per second. Now I need to know how much time is needed to transfer one character or 1 byte only. So I would divide 1 second. This is the time that we need, divided over the total number of characters. So I would get the time per character. So the time to transfer 1 character is 0.00930 seconds over B, or 1 character. And this is the time taken to transfer 1 character. Now, the DMA module will transfer character by character from the DMA to memory. It does not happen in burst. It happens one by one. It does not happen all at once. So we need to know how much time is needed to transfer only 1 character, which we have found over here. So the DMA will steal 1 cycle time to transfer 1 character and slow down the processor. but actually it does not steal one cycle time. It steals in between and delays the processor or makes the processor to pause. So the CPU time consumption when the processor was pausing is actually one cycle time over the DMA transfer time. So we know what our cycle time is. It is the time to execute to complete one instruction, and the DMA transfer time is the time to transfer one character or one word. So 1 microsecond over 930 microsecond, this guy can cancel out, and I need to know this in percentage, so I am multiplying it by 100%. So this gives me 0.11%. So I'll come back with a video on number 8. I am extending the deadline for your submission by the end of today.